Hello, everyone. I was on Twitter recently discussing the C programming language. Someone was talking about how C is sort of terrible because the type system doesn't really help you with anything. Granted, it is annoying. There's not even built-in arrays in C, like at least the way that most programming languages have arrays, like they're not built in. There's a bunch of stuff that's a little bit annoying in C, and it's not the best programming language. It can be really obnoxious to use sometimes, but it definitely has a place in this world, and it's definitely good to learn in a lot of cases, and it's how a lot of systems work, especially Windows and Linux. There's a lot of stuff based and built on and around C. However, their example, one of their main examples that they gave is that, like, you can't run code at compile time. That was, one of the examples. You can't really run code at compile time. Now, one of their examples was like a string compare at compile time. So this is basically what we're talking about. String compare, and we're just going to store the results of comparing these two things inside of var here. Now, actually, what I went ahead and did was copied a C preprocessor called DMPP, and it actually, like I mentioned, I just modified it, and it does actually do a compile time string compare. This took me like an hour, maybe two. I don't know. It was a long stream. It was a 4-hour stream, but I was doing a bunch of other stuff. I don't know how long it took me. It really wasn't that long. I don't even look at this code base very often. I'm not necessarily the best permer in the world, but it wasn't that difficult to do a compile time string compare. This is not even a weekend project. This is like before you go to bed project. It wasn't hard. And at this point, you can basically do anything you want because you can just get the text and do anything you want. Now, granted, I didn't make it like I didn't make it great at like parsing these things here. I just sort of made it work, but still, the point remains. This was not hard. Now, to sort of double check and show you guys that it does actually change this code here, if we go to this, there we go. Now it says false. Now, unfortunately, I can't compile the code because I don't know where my header files are. So I got like the Windows standard header files, but they're the wrong header files, and I don't know where the correct header files are. So like if I do go to compile it, let me see, main.i. Yeah, I have like some weird stuff in here where it's I'm not including the correct header file, if that makes sense. But regardless, let's go to our next example. Obviously, some people might say it's not necessarily fair. He meant to like modify the compiler. Granted, I would say modifying the compiler is probably worse than modifying the C preprocessor. If you modify the compiler, then I feel like that's a little bit sketchier than modifying a preprocessor or making a secondary preprocessor, because you want to sort of separate your code out from standard C code. You want to make sure there's a good layer of separation between the two. Maybe have a special syntax for your preprocessor versus the C preprocessor, just so people know, like, this is yours versus a standard preprocessor kind of thing. So I don't necessarily think modifying the compiler is a great idea. That probably also wouldn't be that difficult, but again, it just depends on how you're measuring. But that's one of the other ways we could have done it, is modified a C compiler to do that. Granted, then you'd have to use that compiler every time, and that's where you start running into more issues. So using a preprocessor, I would say, is probably a slightly better option because then it's compatible with every compiler in theory. So anyway, back to this. So we have our string compare here. Now, I have a question for you, the audience. How would I modify this code to get it to run at compile time? To get this string compare to run at compile time, how would I need to modify this code? I just want you guys to think about that and maybe comment down below what your theory is. So I'll give you just a moment to pause or to think about it, and then I'll tell you. Okay, I'm assuming that you paused the video or commented down below or thought about this and tried figuring it out. Now, for the adept of you, you probably already know the solution to this, as it's slightly a trick question. Oops, apparently I was missing a thing here. It's slightly a trick question, and it's a bit unfair. because I do already know the answer to this, and this is something I've already checked before. But let's actually go look at this here. So this is the result. Obviously, when we compiled it, we got our string compare here. I'm actually not entirely sure what that is, but we also have our, like, one reason why we want this compile time string compare is so that we can actually do like a compile time if statement as well. And we can't do a compile time if statement with this, right? Like, I can't use this to get a compile time if statement to then switch between these two things. So it's a little bit annoying, right? Like, we would just want to be able to just say, generate the correct executable with only the one print statement. Now, if I change this, we actually get that exact thing that I described. We get same, we get call to puts with same. So this is our same LCO. This is same. We're moving it into EDI. We're calling puts. We're passing same to puts. And then now we're resetting our values and returning. So literally, if you want to see another example of this, this is what happened to our code. In fact, as you can see, nothing changed when I deleted all that code. So this right here just recompiled. If I go back now, oops, that was the wrong button. There we go. Nothing changed. And that is because this string compare is actually running at compile time. This if statement is being collapsed down because it knows that this will always be true. And because it knows this is always true, printf same is the only thing that could ever run. So it actually does the stir comp at compile time and the if else statement at compile time and returns to you the exact result that you would want and expect. That's just how awesome / cool a lot of these C compilers really are. They just run these things at compile time. If you know what you're doing, you're just going to get compile time code execution. And again, with Clang, we get the same results. Again, basically most modern compilers, TCC obviously doesn't do this. Obviously Zig is going to do the same thing for Zig CC here. Again, compile time code execution without modifying the compiler, and it works with GCC and Clang. I believe it also works with the Windows default one as well. I don't really know exactly. Most compilers that are trying to produce relatively optimized code are basically all going to give you the same thing. I mean, this is -O. It's not -03, it's -O. I mean, maybe it's also -01. I don't really know if there's a difference here. I mean, obviously the output is the exact same in this case. So again, in C, if you know what you're doing and you understand the compiler, you can actually get compile time code execution if you know what's going to happen with something like this. Granted, it doesn't necessarily happen in debug mode, and it would be nice to be able to do this explicitly rather than having to do it implicitly. However, like I mentioned before, I actually do have like this thing here, which is another sort of option for this, right? The C preprocessor is normally how you do things at compile time. You can just modify it and just have your own version of something like this. Now, I actually didn't try and see if it worked with if. Regardless, the point remains, you can make your own tooling. If you really need something like this, if this is something that's important to you, make your own. It's not that difficult. You can do that. You can make your own version of the C preprocessor or modify someone else's. It's realistically not that difficult to do. So there's basically several different options here. We can just run straight C code. That's one option to run C code at compile time, is just using a C compiler and running it at compile time, or just running the compiler. Like it will just do it at compile time if it can. The second option is using a preprocessor and just modifying it and getting it to work the way you want. Another way is modifying a compiler I think this is probably the least of the solutions. This is not a great solution. You basically only do that when you know you're probably only going to be using one and you want to do something pretty specialized. It's still a pretty good option if you need better type information. So you can absolutely do this kind of thing, have your own custom attributes for functions so it will generate things a little bit differently. I've actually seen that in the wild where people will have their own versions of Clang for modifying things or generating code, or being able to get better type information out of the compiler, and doing stuff like that. The next option is just again using a different compiler, or using a different compiler with an extension that may or may not be common. For example, C even has a compile time parallel for each, for example. I actually have an example of this. There's a lot of different things that C is able to do that people just don't realize are pretty common extensions. So this is actually called OMP. So this is omp.h. If I go to this, we have pragma omp parallel 4, and it will actually run this loop in multiple threads. This is a compile time for loop in C. It's just that easy to have a compile time for loop in, not compile time, sorry, a parallel for loop is that easy to have a parallel for loop in C by just using extension. So you can just use a specialized compiler. Now, granted, this one's actually a pretty common extension, works in CL, Clang, and GCC. But you can just, like I said, use a specialized compiler for whatever you're really wanting to do here. Another sort of example of this would be using like the D compiler, C compiler. So the D programming language actually has a built-in C compiler, and that the D compiler, if I remember correctly, has a thing for doing compile time code execution in C as well. So you can actually do compile time code execution in the C programming language using the D compiler. It's something that's built into the D compiler, and C ends up getting the benefits of that as well because it's something that D does with the AST, and the C code gets compiled down into the AST. So this is something that you can do in several different ways here. Granted, some of these are a little bit ridiculous, you might say, but you can also use, I guess you could call this one a special C compiler. You could have a modified C compiler, you could have a special C compiler, make your own C preprocessor, make your own, just run the C code directly, or even just run an exe. This is actually a relatively common solution, right? There's not that big of a difference between like what is the difference between an executable and a modification to the preprocessor, right? One is machine code in the preprocessor and one is machine code on your hard drive. There's not that big of a difference in my mind in terms of between the two, like an executable and a modification to a program. It's very different in intent, but anyway. The thing with this here, this is STB, and STB actually has a C lexer, for example. A lot of languages actually have these kinds of things built in. So like, for example, the Odin programming language actually has a Odin parser built in, specifically for parsing Odin code for doing these kinds of compile time code generation. So what they do instead is they don't actually run the code at compile time, which they do have some utility for this, by the way. Odin's a pretty cool language, but specifically this is for parsing Odin code and then using that information that you got by parsing the code to then generate more Odin code. So this is basically for macros. You just parse the code using a parser and then generate whatever code that you're wanting to do. And this is why STB has a C lexer, and why a lot of different projects have an extra build step before building the program. And a lot of times they'll run an executable to parse through the code base and generate C files, and then run the C preprocessor and then the compiler. It's, like I said, relatively common for different projects. Anyway, compile time string comparison. It's really not as difficult as it sounds. Obviously, you might say this isn't necessarily fair. It's a C preprocessor, but again, the compiler also does it. You can just run the code at compile time by just having it compile your code with -o. It will figure it out if the code is actually constant. And again, you could make your own C compiler, modify a C compiler, and or use someone else's C compiler with an extension. There's a lot of different options here. Now, obviously, this doesn't really get to the person's point on Twitter, but hopefully this inspires you that you can actually make your own tooling. You can do some really cool stuff, make your own tooling. If you have a problem with a programming language, there's probably a way to fix it. It might not be the way that you expected or the way that you wanted it to get fixed, but there's probably a way to fix whatever problems you have in general. You might have to think a little bit outside the box. You might have to understand, what are we really doing? What is the question that we're asking? We want to compile time string compare. Is this what he wanted? Is this what the person on Twitter wanted? Because this also is a valid solution. What is it that he wanted? What is it that you want? What's the problem that you have, and how do you solve it? And if you think creatively, you can probably find a way. Anyway, have a great, wonderful, sublime day, and get hacking.